Today's episode is brought to you by CuriosityStream. CuriosityStream is a subscription streaming service that offers thousands of documentaries and non-fiction titles from some of the world's best filmmakers, including exclusive originals. It's available on many platforms: web app, Roku, Android, Xbox, smart TVs, iOS, Chromecast, Amazon Fire, Amazon Kindle, and Apple TV, and is also available worldwide. Today I'd recommend you head over to CuriosityStream and check out Breakthrough. It's a fun docuseries with episodes on space exploration and volcanoes, both topics we've talked at length about on this channel. If that sounds interesting, go to curiositystream.com for unlimited access to the world's top documentaries and non-fiction series. And right now, you guys can use the code GEOGRAPHICS at checkout to get 25% off the cost of an annual subscription, which comes out to only $14.99 a year, which is crazy cheap. Go to the link below, or again, curiositystream.com/geographics to get 25% off right now. And now today's video. For eons, it was the inner solar system's great mystery. The first planet from the Sun, Mercury, is also one of Earth's closest neighbors, joining Venus and Mars among the group of celestial siblings we call terrestrial planets. In this case, though, closeness didn't breed familiarity. While humanity spent centuries projecting fantasies of alien tribes or lush rainforests onto our immediate neighbors, Mercury is always the odd one, the world with the strange orbit, the awkward stranger loitering at the edge of the planetary party. The craziest part? Even now, way into the space age, things haven't really improved. Mercury is still the outsider, the terrestrial world we've visited least. And the mysteries have only gotten deeper. In the latest of our space-themed videos, Geographics is traveling within spitting distance of the Sun to examine an improbable planet, a brutish place of hellish days and freezing nights, a place with an inexplicable magnetosphere, a place we're only just beginning to finally understand. A mere 58 million kilometers from our Sun, on average at least, spins one of the night sky's enduring mysteries. As the smallest planet in the solar system, Mercury clocks in at a mere 1/3 of the width of Earth, so small that it barely edges out our moon in the size stakes. Where other moons are concerned, it's actually smaller. Both Jupiter's Ganymede and Saturn's Titan dwarf Planet 1 as easily as the muscular beasts of the Body Improvement Club dwarf small, skinny Mob. But just as Mob's unassuming exterior a powerful core, so too does Mercury have more to it than meets the eye. While it may be smaller than some moons, Mercury has a far larger mass. That's because it's supremely dense. Only Earth is made of denser material. But this denseness is minor compared to the other things our neighbor has going on. Put simply, the first planet is fascinatingly odd. One example of this is its strange orbit. Rather than going whizzing around in a nice regular circle, Mercury instead takes on an elongated route that swings as close to 47 million kilometers to our star before zooming as far away as 70 million kilometers. At the same time, it rotates at a stupidly slow pace. Rather than 24 hours, the average day on Mercury lasts 59 days. Or you just somehow stand on the surface without dying and look up. The result of this combined odd orbit and slow rotation would be the most bizarre set of sunsets ever. From your perspective, the sun would seem to set, suddenly decide, I'm going to play a little bit more, and then rise again, before at last settling for good, effectively ending every single day with an encore. And speaking of the Sun, our friendly neighborhood star wouldn't look quite as you're used to seeing him in Mercury's skies. This close to the Sun would appear 3 times bigger than it does on Earth. Its brightness, meanwhile, would increase by a factor of 7, nor would it dim across the year. With only a 2-degree tilt, Mercury essentially doesn't have seasons. It gets blasted by the Sun all the same, no matter when in the year it is. And you better believe that this closeness to our parent star causes all sorts of extreme conditions. There's the sheer speed Mercury swings through space, covering 47 kilometers in a single second, giving it a year of just 88 Earth days, the fastest of all the planets. And then there's the utterly awful temperatures that it's subjected to. We mentioned a second ago how unlikely it would be for you to be able to stand on Mercury's surface without dying, and that's because temperatures in the sunlight can reach 430 degrees Celsius. That's high enough to do to your face what the opening in the Ark of the Covenant does to Nazis. Now, this isn't the hottest planetary surface. Venus's atmosphere is so thick it traps more heat. Unlike Venus, though, Mercury also has a sideline in bone-shattering cold. Try and run away from the face-melting sun, and temperatures on the night side plummet to minus 180 degrees Celsius. Not that heat and cold are the only things you need to worry about. Bathed in intense solar radiation, Mercury is utterly inhospitable to life, a fact not helped by its lack of atmosphere. In its place, Planet 1 has an exosphere, a super thin layer of molecules which, as NASA cheerfully informs us, is made up of atoms blasted off the surface by the solar wind. Needless to say, this would not be conducive to sunbathing. Still, we don't want to give the impression that Mercury is nothing but a depressing hellscape. It's a whimsical one too. For whatever reason, astronomers way back when decided to name all of Mercury's features after artists and writers. That means it's the only planet to sport a crater named Dr. Seuss. Yet it's not cats in hats or hearing a who that keeps drawing scientists back to the tiniest of worlds. After all, a planet's a planet, no matter how small. And we've barely scratched the surface of the weirdness that tiny Mercury has to offer. Of all the invisible things we should spend every day thanking God for, our magnetosphere must be number one. The invisible shield that protects our planet from cosmic rays. It's the reason life was ever able to evolve on Earth's surface. The reason you're alive and watching this video right now. Brilliant. It's also pretty unique in our part of the solar system. Of the terrestrial planets, Earth is the only one to have a magnetosphere. Apart, that is, from Mercury. Compared to our magnetic fields, the first planet's is laughably weak, a mere 1% of what's generated by our core. But the fact that it's there at all is kind of amazing. Venus doesn't have one, at least not an inherent one, it's generating itself. But there is tiny Mercury, powering this global field like it ain't no big deal. Stranger still, that field is stronger in the northern hemisphere. Again, stronger here, definitely a relative term. No matter what pole you're standing at, Mercury's magnetosphere is pretty flimsy, although its sheer proximity to the sun means the intense solar wind can sometimes interact with it to create powerful magnetic tornadoes. Yeah, the most fascinating thing about this magnetosphere isn't the freaky effects it triggers, but what's causing it in the first place. For that, we have to turn to Mercury's unusually large core. Like Earth, Planet 1 has a metallic core. That's one that's at least partly molten. Unlike Earth's, though, it's bigger than it has any right to be. The core that currently exists beneath all of our feet makes up just 15% of our planet. For Mercury, it's more like 85%. In other words, Mercury is basically a big magnetic field generating core flying through space that's had the temerity to dress itself in a thin outer shell and call itself a planet. And that outer shell really is thin. Mercury's mantle and crust together extend only 400 kilometers. Just like the uneven magnetosphere, the non-thick mantle is an enduring mystery. Although people have made some pretty dramatic guesses as to what caused it, the most dramatic of all being the super Mercury theory. The idea goes that billions of years ago, Mercury wasn't the runt of the planetary litter, but a respectable world at least twice its current size. At some point in the distant past, something unimaginably gigantic smashed into it with such force that Super Mercury basically collapsed. Most of its outer layers were stripped away, flung out into space, leaving only a core shrouded by a delicate layer of rock. Unbelievably, something we actually have proof of this. In 2022, scientists at France's University of Lorraine analyzed an obscure category of meteorites known as orbrites. Of the 70,000 known meteor fragments on Earth, orbrites are among the rarest. Only 80 exist, compared with at least 300 that originated on Mars. First discovered in 1836, they are whitish with metal traces, few oxygen molecules, and most likely they were created from the vast amount of magma found sloshing around somewhere. The French paper noted this would match the conditions on a supermercury just pummeled by a gigantic impact. The researchers theorized that the debris from this crash got hurled all the way out to the asteroid belt, where it remained for billions of years before a handful of them eventually fell to Earth as orbrites. Now, if that's the case, then we have solid proof of supermercury right now in multiple museums. To be clear, this is just one theory. Not everyone agrees with it. Plenty of scientists dispute that orbrites have anything to do with the evolution of Mercury. In fact, not everyone thinks you even need some ancient demolition derby to explain Mercury's small size and unusual core. It could just be that Planet 1 took an evolutionary path that we've never seen before. So these are some of the current Mercury mysteries that scientists are puzzling over. But the most impactful are actually the ones we've already solved, because it's not just in recent decades that we've started trying to puzzle out our overlooked neighbor. For centuries now, Planet 1 has been at the heart of questions so fundamental that answering them reshaped the whole of science. Because it's visible to the naked eye, Mercury has been known to humans pretty much ever since the first caveman looked up and wondered what those strange lights in the sky were. For the ancient Greeks, it was Hermes, the winged messenger god. For the Babylonians, it was Nabu. It wasn't until the Romans came along that the first planet acquired the name that we know it by today, Mercury. Mercury was the Roman name for the god Hermes. But while planet Freddy was known in the ancient world, it wasn't until the dawn of the early modern era that it really started having an impact. Specifically in the 17th century, Johannes Kepler used the planet to prove the accuracy of his astronomical tables. Back then, data weren't something that astronomers normally shared, but something they guarded. That meant building up accurate tables could take a lifetime, perhaps more. The Rudolphine tables Kepler had worked on were the culmination of both his lifetime and that of his predecessor, Tycho Brahe. They were intended to be the most accurate ever created. Not only that, but Kepler had used his 3 laws in the tables to predict where the planets would be visible in the future. That meant the tables being right would also prove his theories. Now, we've got a whole video on Kepler on the Biographics channel if you want to check out the details, but the important point is that Kepler used his tables to predict a transit of Mercury across the Sun on November 17, 1631. Although the man himself died a year before, Mercury turned up just a few hours later than he'd predicted, and so Planet 1 helped cement Kepler's reputation. It also helped set off a remarkable chain of scientific events. The first was the discovery of gravity. 50 years after Kepler's death, Isaac Newton would become obsessed with the Rudolphine tables, which implied some constant force must be guiding the planets on their journey. Eventually, this would blossom into gravity and the entire concept of Newtonian physics, a model that lasted over 200 years. But it was also a model with a tiny problem. For some bizarre reason, it seemed Mercury refused to play by the rules. The issue was Mercury's perihelion, a fancy way of saying the point where it gets closest to the sun, or rather, points, plural. The perihelion of Mercury, kept moving ever so slightly, shifting to a new angle on every orbit, a fact Newtonian physics couldn't explain. But because the universal law of gravitation worked with every single other object, old-timey dudes came up with an explanation that fit within this framework. There simply had to be another planet beyond Mercury's orbit, so close to the sun that it could hide in the burning light, visible only by its gravitational tug on Mercury. By the mid-19th century, they'd even given this invisible planet a name, Vulcan. To be fair to these long-dead astronomers, hidden planets affecting orbits weren't exactly unheard of. When William Herschel first caught whiff of Uranus in 1781, it was noted that the new 7th planet likewise had an orbital discrepancy. In 1846, Abbé Jean-Joseph Leverrier decided it must be due to an undiscovered planet, he used Newtonian physics to calculate exactly where the planet would be, and with style that can only be called epic, went on to discover Neptune that very night. So, the idea that unseen Vulcan was tugging at Mercury made perfect sense. In 1859, a French astronomer even claimed to have sighted the missing planet. But, as we future guys know, there was no undiscovered planet closer to the sun. Instead, Mercury's weird orbit was due to something far more interesting and far more revolutionary, something that would turn science on its head, the theory of general relativity. In November 1915, Albert Einstein detailed this new theory to the Prussian Academy of Sciences, including the idea that large mass objects cause the fabric of space-time to curve. Now, this was a hell of a claim to make, up there with you or I announcing that we've built a working television out of custard. But Einstein had proof. If his new theories were correct, you'd expect the sun's gigantic mass to warp space-time around it, leading to a small amount of instability in Mercury's orbit. A small discrepancy exactly like the one everyone already knew existed. And that was how solving Mercury's most enduring mystery helped prove the most revolutionary physics theory in modern history. Here's a weird fact about Mercury. It's technically the closest planet to Earth. Yep, we know what you're thinking. Surely the closest planet must be Venus, and you'd be right, at least at the point that it comes closest to Earth. Venus is far closer than Mercury ever gets. But here's the twist. At its farthest point from Earth, Venus is right on the other side of the Sun. All the planets are, which means that on average, the planet closest to Earth is the one with the fastest orbit. As we already mentioned earlier, that planet's Mercury. Of course, this requires defining closest in a super specific, pretty annoying way, but we're highlighting this factoid because it leads nicely to an important question. If Mercury is so close to Earth, how come we've barely ever visited it? In the whole history of space exploration, only 3 craft have ever made it to Planet 1. Mariner 10, which conducted 2 flybys in the 1970s, Messenger, which went into orbit in 2011, and BepiColombo, which has done 2 flybys recently and will enter orbit in 2025. Now compare that to Mars, which has seen scores of missions, or Venus, which has seen dozens. Heck, even Saturn has had more missions than Mercury, and Saturn is crazy far away, over 1 billion kilometers distant, even at its closest point. Of the 8 main planets, only Neptune and Uranus have been probed less than Mercury. Yet the fact that we've sent even 2 orbital missions to Planet 1 becomes impressive when you discover why we rarely visit. Reaching Mercury safely, you see, requires more energy than sending a probe to Pluto. For this, you can thank the behemoth at the heart of our solar system, the Sun. As the biggest mother around, our planet star sits at the center of an enormous gravity well, one Mercury is zooming around the edges of. That means simply firing a rocket at Mercury won't do it. Your probe will reach Planet 1 alright, but by then it would be moving so fast that it wouldn't be able to slow down, it would go whizzing past at high speed. It's sort of like you're zooming down a steep mountainside on skis, and you want to stop. The problem is, you're on skis, and you're already accelerating so much that coming to a complete halt on the slope is pretty much impossible. Been there. In an extremely simplified way, that's the issue any craft heading towards Mercury faces. Getting there is easy, stopping is the hard part. Hence why Mariner 10 wasn't sent to Mercury until 1974, over 10 years after the first successful Mariner probe reached Venus. Hence too why Mariner scientists weren't exactly all like, that was easy, guess we should visit Mercury more often. Instead, Mariner 10 would spend 35 years as the only probe to ever get up close and personal with the first planet. The photos it took of a crater-pocked surface, something like our moon, would be the only images we ever got to pore over. The data it beamed back, including evidence of a magnetic field, is the only clue that something strange might be going on. It would take a dramatic discovery to make NASA seriously start thinking about a return mission, and that was ice. The readings that came back from Mariner 10 had suggested there might be craters on Mercury so deep their bases were permanently in shadow, places where ice could feasibly exist. But it was only in August of 1991 that the Arecibo radio telescope detected bright patches near Mercury's poles that might signify frozen deposits of water. And that was super important because for decades now, NASA's mantra when exploring our solar system has been to follow the water. Whether that's ancient riverbeds on Mars, or ocean moons orbiting Jupiter, or frozen polar caps on Mercury. Suddenly, it looked like Planet 1 was going to get another visitor. It's kind of remarkable today just how dramatic the 2010s were for space exploration. While we were all distracted by earthly worries like the rise of populism and the end of Breaking Bad, robotic probes were quietly zipping off to our planetary neighbors and making awesome discoveries. There was the Dawn mission on the underrated Dwarf Planet series, the New Horizons flyby of fan favorite Pluto, the Juno mission to Jupiter, a whole host of new rovers touching down on Mars. But the one that kick-started it all was arguably one of the most impressive of all. The Messenger mission to Mercury. Although it entered orbit around the first planet in 2011, the actual launch of Messenger took place years earlier, in the heady days of 2004. That's because scientists had figured out that a long, looping journey was the only way to slow the probe enough to get around the problem of the sun's gravity well. Using a technique known as gravity assists, NASA was able to have Messenger visit multiple planets, each flyby arriving at the perfect angle to rob the craft of some of its energy and slow it down enough to allow Mercury's weak gravity to capture it. In the end, it took 1 flyby of Earth, 2 of Venus, and 3 of Mercury itself for Messenger to reach that stage. 5 flybys overall over the course of 6.5 years, but in the end it was all worth it. In March of 2011, Messenger at last entered a stable orbit around Mercury. What it found there would change our image of the first planet forever. Prior to the probe's arrival, the common assumption had been that Mercury was just an inert ball of rock, about as exciting as a Liz Truss speech on cheese imports. Now Messenger set about turning that assumption on its head. It confirmed the existence of water ice in some craters, discovered hints of a volcanic past, measured the magnetic field, and uncovered its odd discrepancies. In fact, pretty much everything we covered in the first 2 chapters of this video are entirely due to Messenger's groundbreaking discoveries. And in the end, break grounds is what it literally did. As it ran out of propellant in 2015, Messenger was deliberately directed to crash into Mercury. On April the 30th, it impacted the surface at over 14,000 kilometers per hour, enough to create a whole new crater. By this point, the probe had mapped nearly the entire surface of Planet 1. It had sent reams of data for us to chew over, alongside a galaxy of photos showing it at angles and in colors that we never dreamed of. From an awkward stranger hovering on the edge of the planetary party, Mercury had become almost familiar, a world with mysteries that were being slowly stripped away. And the best part? In just a couple of years from now, a second probe is going to lift that veil even further. Known as BepiColombo, the follow-up craft is a joint mission between the European Space Agency and Japan's JAXA. Consisting of 2 separate probes, it will examine Mercury in detail that not even Messenger could achieve, exploring the inner structure, examining its exosphere, and trying to solve once and for all the mystery of magnetic fields. Already, BepiColombo is well into its long looping journey. Launched in 2018, it's already performed flybys of Earth and Venus. In October 2021 and June 2022, it even conducted flybys of Mercury itself, returning a handful of pictures for us to gawp over. But this is just the beginning. It'll be once the 2 probes enter Mercury's orbit in December 2025 that the science really starts, that we have our best chance yet to stop seeing the first planet as a stranger and start seeing it as a familiar neighbor. As we end this video then, it's with the sort of sign-off that we love doing on these space episodes, the one where we look towards a future mission that will hopefully teach us things that we didn't even realize that we wanted to know. We mentioned a moment ago that the 2010s were a surprisingly fruitful time for space exploration, how it was one of those unsung success stories of that confusing decade. Well, right now, missions like BepiColombo stand to do the same thing for the 2020s, to give us a break from the unrelenting grimness of war and pandemic, and remind us that just sometimes humans are capable of wonderful things. And the most wonderful of them all may be that we're finally able to repeatedly visit the planet closest to our sun, the impossible planet that kept its secrets locked away from us for so long, the planet known since Roman times as Mercury.